Okay, the last section in this chapter deals with solving rational equations. And when we're talking about rational equations, we're talking about equations that have fractions in them. And the key to these, remember when we were doing complex fractions in the last section, we had to find an LCD and then we multiplied every term times that LCD in order to kind of clear our fractions. Well, we're going to do the same exact thing with these rational equations. You're going to need to, first of all, find the LCD, and that might involve factoring. Most of the time it will. So find your LCD. Then you're going to multiply every term by the LCD. And then you're going to solve for x. Now, if you end up with an x squared, we're going to have to factor. If you end up with just an x, that you have to combine like terms and you just have x's, we'll just be solving for x and it'll be as simple as that. Now, something else that we have to think about is we have to think about our domains. When we are looking at these fractions, remember we can't let the denominator cannot equal 0 because that's bad. So when I'm looking at mine, after I find the LCD, I'm going to look at my denominators and make sure I check to see what numbers I can't use ultimately in an answer, because we're going to get answers. We're going to get number answers for these. So I look at the beginning, like for instance, in this first one, this example that they worked for you, I've got an x plus 5 and an x minus 5 in denominators. So the number that would make x plus 5 equal to 0 would be a negative 5. So if I get that for an answer, I can't use it. In the second fraction, I've got x minus 5. So if that were a positive 5, that would be a 0. So I can't use negative 5 and 5. So I'm going to look down at the bottom. They got a 30 for an answer, so 30 is okay to use. Because if I had gotten a negative 5 or a 5, I would have had to have thrown it out. Okay, so let's do some examples on the next page. Okay, looking at this one, x plus 32 over x equals 12. My LCD is going to be x. That's the only fraction I have. And on this one, x cannot be equal to, since I only have a single x, I'm having to watch out for 0. So what I'm going to do is I'm going to multiply every term times x. And it gets a little crowded. If you want to rewrite it, rewrite it. X times x would be x squared plus the x and the x would cancel, and I'd have a 32 equals 12 times x is 12x. Now, since this has an x squared in it, I know I'm going to have to ultimately factor. So I need to bring the 12x over here with the 32 and the x squared. So that gives me x squared minus 12x, we're going to write in descending order, plus 32 equals 0. So I need to find factors of 32 that add up to negative 12. And I believe those would be 8 and 4, but I need a negative 8 and a negative 4 to get a negative 12 in the middle and a positive 32 at the end. Now, if you'll remember from quadratics, once you factor, you take each factor and you set it equal to 0. So we're going to do that. And to solve this one, I'm going to add 8 to both sides. So you end up with an 8 for one answer. And I'm going to add 4 to this one. And you end up with a 4 for the other answer. So 8 and 4 are my answers. I can use 8 and 4 because remember the only number I had to stay away from was 0. Okay, so not too bad. Pretty straightforward. Let's look at the next one. This last fraction is not factored. It's the difference of two squares. So x plus 3, x minus 3. So I'm going to multiply every term times x plus 3, x minus 3. Now, in this one, since it's so crowded, I'm not going to write it all next to every one. Let's see if we can do it without writing it. In this first one, underneath the 4, the x plus 3s would cancel, so I'm going to have a 4 times an x minus 3. I'm going to come over here and write my LCD was x plus 3, x minus 3. I'm getting ahead of us. Okay, then with the 6, there's a minus in front of it. The x minus 3 and the x minus 3, those would cancel. So I'd have 6 times x plus 3 equals. Now on the bottom of the 4, I've got both of the parentheses. It would cancel with both of the parentheses, so I just have equals 4. So let's clear our parentheses. 4 times x is 4x. 4 times a negative 3 is negative 12. A negative 6 times x would be negative 6x. Negative 6 times 3 would be negative 18 equals a 4. This one's nice. We're not going to have to factor because I don't have an x squared. Let's just combine like terms. 4x minus 6x would give me negative 2x. Negative 12 minus 18 is a negative 30 equals 4. So I'm going to add 30 to both sides. So negative 2x equals, sorry about that, 34. Divide both sides by negative 2. So x equals negative 17. Now, I forgot to go back and ask myself, what numbers can I not use? Well, we have a x plus 3 on the bottom and an x minus 3 on the bottom. So what are the two numbers I need to stay away from? Do you know? Negative 3 and 3. And 17 is okay because that doesn't equal either one of those. All right, let's look at the next one. We've got 16 over y minus 16 over y plus 1 equals 2 over y. So on this one, my LCD, I have a single y. It's got to be there. And then I've got a y plus 1. It's got to be there. And so on this one, y's cannot equal. I can't have a 0 because I have a single one in there. And then the second fraction, I couldn't have a negative 1. That would be bad. So I'm going to multiply each one times y plus 1. So in this first one, the y's would cancel, and I'd have 16 times y plus 1 minus, in the second fraction, the y plus 1's would cancel, and I'd have minus 16 times that single y equals, in the underneath the 2, the y's would cancel, and I'd have 2 times y plus 1. So let's clear our parentheses. 16y plus 16 minus 16y equals 2y plus 2. On the right side, 16y's on the left side, 16y's cancel. So I have 16 equals 2y plus 2. I don't have to factor on this one. Just subtract my 2 from both sides. So 2y equals 14. So y equals 7. And 7 is okay to use because remember 0 and negative 1 were my bad numbers. We getting the hang of it? Not too bad. Okay, let's look at this one at the bottom of the page. I have an x minus 4 in one fraction and x plus 4 in the other. So that leads me to believe that my LCD's got to be each one of those. And on this one, my two numbers that I've got to stay away from, if I have a 4 in that first fraction, that would be bad. If I have a negative 4 in the second fraction. Okay, so I'm multiplying times x minus 4, x plus 4. Underneath the 7, the x minus 4's would cancel, and I'd have a 7 times an x plus 4 equals, now, a 1, I'm going to go ahead and write this one next to each one of those. I'm not canceling anything with the 1 because the 1 doesn't have a fraction on the bottom of it. So that means I'm going to have x minus 4 times x plus 4 because it would be 1 times those. I don't have to write the 1. Then the 9, I've got a plus 9. the x plus 4 would cancel with an x plus 4 on the top, so I'd have a 9 times x minus 4. That may take some going back and looking at to see and make sure you understand what I did just then. So let's clear our parentheses. 7x plus 28 on the left side. Now on this one, I'm going to need to FOIL. And these are conjugates of each other. So when you FOIL it out, you should get an x squared minus 16. Okay, then I'm going to distribute the 9. And so I'm going to have plus 9x minus 36. Okay, so nothing's happening with the left side yet. Let's combine like terms. I've got an x squared, I've got a plus 9x, and then negative 16 minus 36 is going to give me negative 52. Now this is an x squared one, so I need to bring everything over and factor. So I'm going to subtract 7x from both sides, and I'm going to subtract 28. So then that's giving me 0. I'm going to have x squared. 9 minus 7 gives me 2x. And negative 52 minus 28 gives me negative 80. So factors of negative 80, the first thing I think of are 10 and 8. 10 times 8 is 80. And so 10 minus 8 would be equal to a positive 2. So that means I'm going to have an x plus 10 and an x minus 8. And when I set each one of those equal to 0, I'm going to get negative 10 for one answer. And I'm going to get positive 8 for my other answer. And those two answers I can use because remember 4 and negative 4 were my bad numbers. Okay, let's do this last problem on the back. On this one, I've got the first two are already factored. I can almost bet you factors of 30 that add up to 11 would be plus 5 and a plus 6. So my LCD then ends up being x plus 5 and an x plus 6. So let's think about my bad numbers, numbers I can't use. In this first one, if I had a negative 6 there, that would be bad. In the second one, if I had a negative 5, that would be bad. So I've got to watch for those numbers at the end. So my LCD is x plus 5, x plus 6. Got a little bit more room on this page, so I'm going to actually do the writing next to each one. Okay, so on this first one, x plus 6 is cancel. So I have a 1 times the x plus 5. On the second one, x plus 5 is cancel. So I have a plus 4 times an x plus 6 equals. On this one, both parentheses cancel. So on top I have a negative 1, so it stays a negative 1. So now we're going to clear our parentheses. So I'm going to have x plus 5 because 1 times both of those is just going to be. I'm going to have a plus 4x plus 24 equals negative 1. Now in this one I'm not ending up with an x squared, so we're just going to collect like terms on the left side. X plus 4x would be 5x. 5 plus 24, that gives me 29 equals negative 1. So I'm going to subtract 29 from both sides. I'm going to have 5x equals negative 30. Divide both sides by 5 to solve for x. So I get a negative 6. But look back up here at the numbers we said were the bad numbers. Negative 6 was one of those numbers. So that means that I cannot use this negative 6 that I just got for an answer. And in fact, the negative 6 was the only answer I got. I didn't get two answers on this one. So if I've got to throw out the answer that I just got, I don't have any other options. That means that there's no solution. because the solution I got when I worked it out, I'm not able to use because it would make me have a 0 in the denominator. So just be careful and watch for those. They happen every so often. Most of the time you're going to get an answer you can use, but every so often you're going to get one that you have to throw out and you won't be able to use it.